And welcome back to part 2 of programming DynamoDB using the AWS NodeJS software development kit. Okay, so we just jump into our Atom IDE, and what we're going to do is connect up into our Node.js EC2 instance. So if you haven't already created that, go back to the introduction lab where we introduced you to setting up a Node.js development environment using EC2. So go back to that if you haven't already done it. So I'll assume that you have. And what we do now is we just go into Packages, Remote Edit, and we browse our hosts, and we select our host from the list. So once we've connected in, we'll select our index.js file. Okay, select that index.js. So what you'll need to do now is to grab all this, delete it all, and put the code that is in the lab notes. So this code is actually correct now because I've already done this before. So I'll just go through this. Obviously require the software development kit, so that's the require command there. So very important here, don't hard code your credentials. Yeah. We've created an IAM role, so there is absolutely no need to put your credentials. So those credentials you just should not need to use anywhere at all. So you guard them with your life and use IAM roles instead. Configured our region next, and now we're going to create a AWS DynamoDB object, and we're going to issue a command list tables, which will list all the tables in our DynamoDB database, and will console log those out for us. So we've only really got one table, the test table, so we should just see one table printed out on our console. So once we've done that, we can do Control S and upload that, just to save it and upload it back to our EC2 server. And then we can connect into our EC2 server using PuTTY, and which is where we'll go now. Okay, so we're just now in PuTTY, so we'll just connect into our EC2 instance. Okay, so we're in there, so we'll just navigate to our application. Okay, and we'll just run our node command on that, on index.js. Okay, so what it's done, it's just it's run our application and it's printed out a list of our tables, and there's only one there, test table, so that's working fine. Okay, now so jumping into back into the Atom IDE, so we're just going to now look at creating a function to download data, to download our JSON file, and there's a link to that JSON file in the lab notes, so download that, and then grab that file and put it onto an AWS S3 bucket. This is our bucket name that we've used. Yours will obviously be different to that, and then just create a folder within that bucket called lab-data, and then put the test table items JSON file in there. So what we're basically doing here is we're creating that that function there that's going to be called in the callback for this DB list table. So once that's done, it'll go through and download the data. So we're going to create a new AWS S3 object here. So we created a DynamoDB one up here. So now we're creating an S3 one. We're going to access the S3 service. The parameters we need are the bucket and the key to access that object from the S3 bucket. So S3 get object, pass those parameters in. If there's an error, we just console log that out. If not, we pass that data from JSON to a JavaScript object, and then we console log out that data to the screen. So first of all, we'll have a look at that actual file that we're getting. So here it is here. So what it basically is that we've got a definition here of the table that we're looking for, and then we've got a number of requests here. So put requests against an item with an ID of that, and then we're going to be adding these items too. So that's pretty well straightforward. Then another put to add an item in there with those attributes. and then we go through like that. So here you can see we've got quite a few there all lined up, all ready to go. So you might say that that's quite difficult to do, and it probably would be. But what you can do with this to make life a lot easier is you can actually create this in an Excel worksheet. So if you've got your data there, you can actually concatenate all of the cells together. So you can create this as being one cell here up to where the data is. And then you can put your data in another cell and then create another cell after it. And then just do a concatenate function on that data, and your Excel worksheet, you can just then cut and copy that, cut and paste that into a JSON editor, and it'll format that nicely for you. So we'll just have a look at how this looks like in a JSON editor anyway. Okay, so we just cut that in there, paste that in there, sorry, transfer it across here. So we can see here we've got our test table main object there, and we've got our entries that we're going to put request, item, and that's it all there. So that's how it looks, pretty straightforward. So again, we can create all this nicely in an Excel worksheet, and just use the concatenate command to put that in, and then just cut and paste them over, not a problem. Okay, so what we'll do is go back into the Atom IDE, and we'll Control S to upload that back to our EC2 server. And once that's done, we will jump back into our our PuTTY command prompt. Okay, so that's done, and then we'll run our node index.js. Okay, so we've successfully connected to the AWS S3 service this time, and we've downloaded that file, that JSON file, and we've output it to the screen, so that's fine. So the next thing we want to do is to actually grab this data and process it and put it into items in our DynamoDB test table. So back into Atom IDE. Okay, so what we're going to do now is, after we've downloaded that data, in our success callback, we're going to call another function called write DynamoDB, and that's going to grab that JSON data that we've got, and it's going to write it to DynamoDB using a batch write command. So, okay, so what we've got here is the first thing we're going to do is pass some parameters, which will be the request items, being our data.json, and then we're going to do a batch write command. So we're going to pass those parameters, which will just be our list of our items that we want to add, and quite simply, if there's an error, we console log out, otherwise we'll console log out that data. So we'll just jump back into PuTTY. Oh no, first of all, we won't jump back into PuTTY, we will do Control S to save this. Okay, saving it and uploading it back to our EC2 server. Okay, so that's looking like it's done. So we now run our node again, our node index.js. Okay, so that actually has worked. So what we're looking for is a unprocessed items, which is basically saying that nothing was unsuccessfully processed. So we've basically added all those items to that. So really what we can do now is go into the DynamoDB console and look at our browse items again. So we've got that one there that we looked at originally, the one that we created manually. So now we can start a new scan, and voila, we've got all those additional ones being added into it. So there's our first one that we created manually, and then with just a click of a button virtually, we've created all these new ones. So this is a really good way of bringing data in. So create your data in a Excel worksheet, and then just build your code up from the concatenate command in Excel, and then you can just cut and paste that into a JSON editor to format it, put it into a file, and then run a batch write command, and you can bring that data in. So it's quite a reasonable way of doing it. It's the way I normally bring in data, not a problem. Okay, so now let's have a look at querying that data. So back into the Atom IDE. Okay, so first thing we want to do is now jump into our write DynamoDB function, and in the success callback for that, we will run a query DynamoDB function. So we're basically chaining through here. So the first thing, we're going through and we're connecting into our DynamoDB. In the success of that, we're going to jump into downloading the data from Amazon S3. When that's successful, we're going to jump into write DynamoDB to write it in there, and then once that's successful, we can query the data once it's gone in there. So query DynamoDB function, so that will pass some parameters. Okay, so this is a little bit more complicated. So we've got the table name, the test table, and then we've got a global secondary index that we're going to be using, which is our product category-price.index that we created in the DynamoDB console. And then we've got key conditions. So what we've got here is our product category, our hash, and price, our range. So for our product category, we're going to look for everything that equals, that is a bike, which is string bike. So we're going to look in the product category and find everything that equals bike. And then we're going to look in the range, and we're going to look for everything that is less than or equal to a number 300. So we're looking for all of the bikes that are less than or equal to a price of 300. So a little bit complicated, and we'll look at using key condition expressions, which are a little bit simpler and a little bit easier to understand, but just want to get you across showing you both of the two techniques for querying using the SDK. So again, we do Control S. We upload that to our EC2 server. Okay, so that's done. So then again, we run our node index.js application. Wonderful. So what it will do, it will output to the console all of the bikes that are above, or that are less than or equal to $300. So this one here, it's a bicycle, it's a bike, not a problem. And it is priced $100. The next one here is priced $200, that's fine. And the next one, the last one, is $300 because it's less than or equal to 300. And that's it, that's fine. So if we go into our into DynamoDB console, we can see that's right. So I didn't select that one, so we've got 1, 2, 3. And there's 2 that we didn't get because they were over $300, and we didn't get these because they were booked. So there should be 3 there, and we've got 1, 2, 3 here as well. So that is fine, so not a problem. So now we'll look at a different way of doing it. So just jump back into the Atom IDE. Okay, so I've just pasted in the new query DynamoDB function, and so that's using a key condition expression. So let's have a look at that. So we've got a table name, test table. Again, we've got our index name, the same as before, our global secondary index there. But what we've got here is a key condition expression. So what it's saying is when the product category, so the product category and price is less than or equal to price. Okay. So let's have a look at prod cat. So prod cat is an attribute value here for the expression, and again that's a bike, and then we've got price, which is 300. So now we can put it back in here. So when product category equals bike and the price is less than 300. So it's a little bit easier to understand because you're looking at an expression that's it's not an object as such, so it's a little bit easier to understand, and then you're defining the values that are used in that expression in an object here. So again, we just run that db query command again, and we get the same result for that. So again, we do Control-S to upload that to our EC2 server. Okay, so that's done, and then we'll just run it and see what happens. Okay, so we got a similar result. So we've got here 100, 200, and 300. So both techniques have given the same result, but one of them was a little bit simpler to understand. But it's good to know both ways. So whichever one you prefer, I suppose, use it. But the preferred technique that AWS recommends is to use key condition expressions. So we've covered quite a bit there. So we've used a console to create a table. We've used a console to add items, and we've seen how difficult that can be. Then we've looked at using a JSON file to batch import items into DynamoDB, and then we've looked at the two ways of querying that data using a key condition object or using a key condition expression. So that's it for now, and I'll see you in the next lab.